In today's video, what we're going to discuss is about theory of computation. In the theory of computation, what we're going to discuss is subject code is 21 CS 503. We're going to discuss about one small problem. Myself, Sharmila, Assistant Professor, Department of Computer Science, R.M.D.E. Engineering College. We're going to discuss about the Thompson construction method. Here, the Thompson construction method is about how to construct using that Thompson construction method algorithm. We're going to discuss. There is a three properties. This is the first property. This is a second property, and this is the third property for Thompson construction rule. First rule, second rule, third rule. Here, this is for a parallel, that is R and S is the equation. This is for a series, and this is for the asterisk symbol. That is a rule for creating a Thompson construction method. What I said is that is for 0 plus 1. So here this is for this particular rule 1 is what we're going to discuss is for this rule 1 we're going to discuss is 0 plus 1. So here the 0 plus 1 is 0 plus 1 means the diagram should be in the parallel. So here 0 and 1, other all the state you should write epsilon. Then they are given this asterisk. That is a rule 3, that is for asterisk. So here rule 3, the given diagram is here. You should add one more epsilon state. That is a rule 3. So here we are adding this extra one epsilon state. We have completed up to this asterisk. Now again we should draw for the 1. So here I am creating the next step for this 1. Input is 1. So input is 1. Next one is in the given question 0 plus 1. Again we are drawing using the rule 1, the 0 plus 1. This diagram we are drawing. So this is 0 plus 1. And this is for 1. And this is for 0 plus 1 asterisk. 0 plus 1 asterisk. So the question is given as 0 plus 1 asterisk. So 0 plus 1 asterisk, we are using the rule 1 and rule 3 we have created, and one state rule 2 we have created. Next is using the rule 1 we have created for 0 plus 1. So the given problem is solved using the Thompson construction method. One more method is there, using the computation of K level K0, K1, K2. Using that, we're going to create about that transition using that particular problem, RIJ method. Next application is pumping lemma. Pumping lemma, we have a 3 condition: y not equal to epsilon, x and y less than or equal to n, k greater than 0 means the string x, y power k and z is also belongs to the language, in the given language, that is pumping lemma for the regular language L. So there exists constant n which depends on the language L, such that for every string w in the L, so the length of the W string greater than or equal to n. So we break into 3 strings, that is x, y, z. In that condition, y not equal to epsilon, x and y, the length of the string less than or equal to n, k greater than or equal to 0. In that condition, the string should be x, y power k z is also present in the language L. The application of the pumping lemma is using not regular language and never used to show the language regular. L is satisfy the pumping lemma. L does not satisfy the pumping lemma in the non-regular expression. So for to prove this, a power n, b power n greater than or equal to 1 is not regular. We are using a 3-step. First step is that the given particular language y is not belongs to epsilon. Second condition is that xy length of that is less than or equal to n. The third condition is the particular grammar is belongs to L. So using that, we are proving a pumping lemma. In this video, what we have discussed is how to create a transition diagram using a Thompson construction method. We have a 3 steps: step 1, step 2, step 3. The first step is for 0 plus 1, second step is for 0 into 1, third step is for 0 plus 1 asterisk for asterisk. Okay. Next, we have discussed about RIJ method. Using K0, K1, K up to Kn state, we should use a formula and we should create a RIJ method. Third one, we have learned about what is pumping lemma. What is a 3 condition? That is y is not equal to 0, x and y length of the string is greater less than or equal to n. And the last condition is x power y power z power k equal to belongs to the state L, that is regular language L grammar, the pumping lemma. So I hope you understand this video. Thank you.